Hello all, welcome back to my channel. So in this video we will see about manufactured sand, that is M sand, and about recycled aggregates. So manufactured sand is the most common alternative for river sand, and recycled aggregates are alternative for coarse aggregates. So let's see one about them in detail, advantages, disadvantages, properties and applications. Moving on to the first one, which is manufactured sand. So basically manufactured sand, which is in short called M sand, is a most widely used substitution for river sand nowadays, because dredging of river sand can lower the groundwater table and exploiting the natural resource. So it's like we are searching for sustainable alternative materials in the place of river sand, and M sand is said to be one of the good alternative for it. And basically M sand is produced by the crushing of granite stone. So generally we cut the granite stone into different sizes and different shapes for various construction purposes, and once you are cutting that you get a dust or a powder which is collected, washed and then graded, and that's called as M sand. And basically the size of M sand is also less than 4.75 mm, same like as river sand, which satisfies the criteria of fine aggregate. Coming to the properties of M sand concrete, means once you add M sand into concrete, how does the concrete behave is that we will see. First thing is that based on particle shape, as I've told, M sand particles are angular or cubical, so they contribute to better interlocking of concrete, thereby making the concrete more denser and imparting more strength. And the distribution of the particles also are good enough so that you can also achieve a good workability, like up to medium workability can be achieved. And coming to the finest modulus range, typically for M sand the finest modulus ranges for similarly like fine aggregate, that is around how much is for fine aggregate, that is river sand, the same is applicable almost to M sand also. So you get around 6. Okay. And moving on to density part, generally when compared to natural sand, M sand also has around the same density, little less sometimes, but since it's comparable it can be used as an alternative to river sand. And coming to the texture of the particle surface, basically it is little smoother when compared to natural sand, and there may be little effect in the bonding with the cement paste because of the very smooth texture. So M sand can be used as a partial replacement to natural sand. Coming to the advantages of using M sand, the first thing is that it is very well graded, like all the particle sizes are almost similar to each other and a perfect particle size and texture. So it's good enough to be used into concrete, and it does not contain any organic substances or any soluble compounds. Likewise we see in fine aggregate. To check out my video on deleterious substances in aggregates, where I talked about the impurities in aggregate. Here it is not happening, so that all the properties of the concrete are maintained, and even the presence of impurities is also less, like clay, dust and all is also very less in sand, and therefore the bond between the cement and the aggregate surface is maintained properly. And M sand is also, as I've told, it is obtained from granite, which is actually the state of art. Research is going on this addition into concrete, and also combination of various alternatives of fine aggregate like glass powder and sand together, and their synergic effect is also studied worldwide. And another important advantage of M sand, which I have not included here, is that the cost is less when compared to river sand. Nowadays river sand has become very costly. Moving towards the disadvantages, the first disadvantage is that, as I've already told, due to the surface smooth texture of the M sand particles, even though your workability is more, the bond may be little decreased. So one has to be careful in that. And generally, M sand demands high water content, which is actually not good because you may end up with lower strength. Hence, for low important constructions, we do take the help of M sand. And as the particle size is also very fine, once the particle size is very fine, the demand for water will increase, and thereby you require more water for hydrating all the particles, so which reduces the concrete strength, because we know as the water cement ratio increases, strength decreases. And you may also end up with permeability issues, because sometimes addition of M sand can increase the permeability when compared to natural sand, therefore which affects the durability of the concrete. And one more disadvantage which I have not put here is that with M sand is that generally M sand is little warmer when compared to natural sand. So if you construct a room with natural sand and if you construct the same room with M sand, the room constructed with M sand would be little warm when compared to natural sand. Coming to the applications of M sand in concrete, you can use it for structural concrete members and structural concrete elements application like beams, columns, slabs. You can also use M sand in pavement applications. You can use it for rigid pavements as well as for flexible pavements. You can use for precast concrete members, something like your blocks or pipes or concrete panels. You can also use in the construction of high strength concrete, where you require higher compressive strength, likewise in bridges and high-rise structures. And you can also use M sand in shotcreting, that is where you pump the concrete through nozzles for tunnel lining, slope lining, and for retaining walls, etc. Coming to the next part of the video, which is recycled aggregates. So recycled aggregates are generally used as an alternative for coarse aggregates, natural coarse aggregates, that is a natural stone. So this concept has been built up very widely nowadays, because that as we are moving towards demolition of old structures for the construction of new structures, there is a possibility of extracting coarse aggregates from the concrete. Of course, they would surely have lesser strength when compared to the virgin aggregates, but still, instead of simply dumping that demolished waste onto the ground and filling the land area, that aggregates can be extracted. See, once a building is demolished, people generally take out the metal, take out the wood, take out the glass. Even the aggregates also can be removed and they can be recycled. So, this recycled aggregates sometimes include sand. Even if you are able to extract sand from water, it's good enough. And gravel, crushed stone, and asphalt. Coming to the properties of recycled aggregates in concrete, the first thing is the particle size distribution. The particle size distribution, like the particle size of recycled aggregates, is very similar to the natural aggregates which is obtained from the natural rock, that is the crushed stone, and hence the recycled aggregates meet all the criteria specified according to natural aggregates, and hence they can be used as a alternative for natural coarse aggregate. The absorption capacity of the concrete is little high, because the absorptive capacity of this recycled aggregates is high when compared to natural aggregates. So overall, the workability can be impacted, the setting time will be impacted, strength and durability will be impacted. Moisture content, generally recycled aggregates are extracted from demolished waste, so maybe in their lifetime they could have absorbed some moisture, so they may have some residual moisture with them. And when you are adding again water to make the concrete, the amount of water content would be increased highly, which would lead to reduced strength. So one has to remember that when you are using recycled aggregates, you need to add less amount of water. And coming to density and specific gravity, obviously they are reused aggregates. See, they have already spent their life around 40 years, 50 years in some building, and so their density would have been reduced, and also the specific gravity is also reduced. So generally, the specific gravity of recycled aggregates is around 2.35 to 2.58, which is very less than the natural aggregate. For natural aggregate, it's around 2.8. Coming to the advantages of recycled aggregate, first thing is that amount of virgin aggregates can be reduced, so that you cannot exploit natural stone, because you have to do the process of pouring and all, so that can be eliminated, and reuse of aggregates is done. And even you can contribute to lower CO2 emissions, because it's already a used aggregate, so already so much of amount of carbon dioxide is already lost, and hence that which emits into atmosphere is less. Cost saving, because it's a reused one, so the cost is will be very low. And one important thing is that conservation of the landfill, as I've told, simply dumping onto the land and wasting the space of the land and nutrition value of the land, this is another alternative for replacing, and it creates more employment opportunities in the recycling industry. Moving on to the disadvantages, first thing is that, as I've already told, the density and specific gravity of the recycled aggregates is less than the natural aggregate, so you would end up with low quality of concrete. And as I've already told, the water absorption capacity of the recycled aggregates is high, and this would end up in decrease in compressive strength. Around 30% lesser strength when compared to the natural, conventional concrete can be observed. And workability of the concrete is reduced because water is absorbed by the aggregates because of the permeable nature, so the workability of the concrete is reduced. And we do not have any specific specifications or guidelines of using recycled aggregates into concrete, like how much is the percentage, what should be the specific gravity, what should be the density. Likewise we have for natural coarse aggregates. Obviously the durability is less, and maybe you should, when you are using recycled aggregates into concrete, you need to add other combination of mineral admixtures to, you know what complement the strength, to justify the strength reduction because of the recycled aggregates with those mineral admixtures. Coming to the applications of recycled aggregates can be used in construction of gutters, that is the drains and pavements. Even large pieces of crushed aggregates can be used for building revetments, for slopes, for controlling soil erosion. Even recycled concrete rubbles can be used as coarse aggregate in concrete, what we are currently doing. And production of recycled aggregates also, results in generation of many other byproducts, such as, and it can be also used as a ground improvement material other than usage in concrete. So that's it about this video. Hope you all understood. Thanks for watching.